And we're live. Welcome, everybody, to yet another weekly for the new diffs architecture workflow. We have a point in the agenda. Patrick, you want to start with yours?
Yep. I have our first point. I was reading the agenda last week, so I was wondering what is this mrdiff spark first diff file show metric? Where can I see this?
So if you have, so this is a marking using the timings API that we have. So essentially, the merge request app, or the diffs app, I should say, has a couple of markings along the timeline that is custom made for the app that we built that marks certain moments in the app. One of them is the first diff file shown to the user, like render the first file on the contents of the first file. The way you can see that is you enable the performance bar, and then you open the console when you're rendering the page, and it should output you the log of the marks in that current page that you're in. That's how we made it visible. You can access the API yourself, but this is the easiest way.
Good.
Is that clear? There's many other markings, and we are aware that some of them are kind of like triggered at the same time, so they don't really have much difference between each other, but at least they're there.
So thanks.
No worries. Check. I'm just gonna put it right here. Enable the performance bar and open the console while rendering the page. Okay, go on to the next one then.
Right, the next one's about the highlighting investigation. So just a quick update. So I tested 3-seater highlight, yes. Another highlighting solution, but it's based on Rust. So it's kind of promising because it shows around 80% improvement compared to the Ruby approach that we currently have. So yeah, it's of course it's going to be complex if you're going to use a different service. So the next steps that I want to do is to benchmark Rogue by itself, because I'm thinking maybe it's actually not that slow, but it's slow because we're adding our own customizations to it. So yeah, so I want to make sure of that first before I don't know make my conclusions. Right.
Okay, and it feels like the difference is also smaller. So it feels like the growth between the merge request Ruby file and the JSON is less than using Rouge. Or sorry, I'm probably looking at the. So I'm sorry, what's Chroma? That's another library.
Yeah, it's another library in Go. It's just for comparison.
Oh gosh, so GitLab Highlight is actually even slower than that. Okay.
Yep.
That's definitely promising results. So that's really interesting and important, because I feel like we've been having conversations about potentially doing the highlighting asynchronously. So essentially loading the files not highlighted and then highlighting as we go, as the user goes through the page. Depending on the results of this, we might not need that optimization if we can make that highlighting much less costly. So yeah, keep on digging, I would say.
Yeah, we do. Yeah, next
have
point
the next one.
Yeah, it's me again. So it's regarding the metrics on this issue that was posted. So based on my understanding, this is including the time spent on backend as well. Is that correct assumption?
Yeah.
I see. Yeah. So my follow-up question there is, are we able to track time spent on front end only? Just to see if which one's slow. I mean, pretty sure backend is slow, but I just want to confirm that.
I think we can do that. But that will be kind of misleading when you read this metrics if you measure just the front end, because the slowest part here is backend, and if we add front-end overhead to this equation, we are still delaying the first request to get the first page. So we cannot, at least now, we cannot render just a plain HTML file in 0 milliseconds on the backend and start requesting files as soon as possible. We still have the Rails overhead, and that delays the first request if we use virtual scrolling. So the first batch will be delayed by that anyway. So that's why I measured end-to-end latency. So it's right from where you hit enter in the URL bar and until you see the first file.
Yeah, that's the tricky part, Patrick, is that we're trying to assess how much more performant it is. And if we're doing much more work on the back end with the server-side rendering, it's obviously going to be important to account for that too, because that's perceived performance, right? So we do have some metrics like already available. Like I think the timings API could be one of them, where those are browser tracked timelines. So you can use that, I guess, to get acquainted. I think there's one triggers when the app is initialized, and then there's a bunch of others like on different moments. We can use that if we need to know exactly the front end part of things. But with the server-side approach, that's where things get a little bit more muddled together, and we need to kind of like account for the whole thing to see where how faster it actually is.
Yeah, that makes sense. So I guess I think the follow-up point to this is like, I think the next step is for us in the back end, see like what we can do to make it a bit faster than the current situation. So.
That's a great segue for Stanislav's point, I guess. Do you want to bring that up, Stas?
Yeah, but I will try to approach this from a different perspective. As I've mentioned, we still have Rails overhead, even if you don't render anything on the page. So if you render just a blank page, there will still be like 300, 500 milliseconds of delay before you get anything from the server. And that kind of kills the client-side rendering part here, because if you're doing client-side rendering, you're best serving your assets as soon as possible, which we can do with Rails, unfortunately. At least I couldn't figure out what adds this 300 milliseconds to every single request. So yeah, if we just try to pack things in a single request, like with SSR approach, we try to do as much stuff as possible. That would essentially improve things, because we don't have to include that overhead before making the first request. You are already seeing the diffs, and this overhead kind of negates a little bit. And yes, another thing I've worked on this week is trying out Rails template caching, which should also improve things for server-side rendering. Unfortunately, I couldn't get it to work as a fully streaming solution. So I've enabled streaming for the specific controller that sends server-side rendered diffs, but it always buffers the response. So instead of getting the diffs immediately as soon as they render, you have to wait like 20 seconds, 25 seconds and get the full response at once. I couldn't figure out why that happens. Maybe that's one of our middlewares or something else. If you have any ideas, please share them in the issue. That would be very much appreciated. I also have POC in that issue. Please use that to test it out.
Yeah. Thank you. Thank you for the POC. Yeah, I actually had a look just quick thoughts, because I wouldn't say that I investigated it thoroughly, but if I can share some quick thoughts regarding it, to be honest, I haven't used the streaming functionality of Rails before, but according to the documentation, it's actually performs like the following optimization. It it streams the layout first, and after the layout streamed, it starts rendering the rest of the page, and then when it's ready, it's sent to the client. Why this optimization matters? Just because when you stream the layout, now browser can fetch like some scripts, like style sheets, CSS, and then render the main content. And in theory, it should be faster. So maybe we can check this approach, but maybe it would be more like feasible to use it for some full pages that we rendered to the client. But I also had a look at the action controller live. I remember Stanislav also mentioned it before. And I tried it, and it also didn't work at first. Maybe it's also one of the reasons why it didn't work for you, Stanislav. But then I just read. Just a second. Then I started investigating it a bit more. I noted this that for eTag, when eTag is used, it's not working. So I disabled the headers for eTag and tried it once again, and I received something like this. So just a second. My endpoint, it should show like hello world every 1 second. So stream the response like hello world every second, 5 times. So it started working, but the bad news that this model is not used in our application at the moment, and so we are not really sure what are the performance implications of executing like a separate thread to stream the response. It's one thought about it, and the other is whether it's an appropriate solution from a front-end perspective. Maybe you can let us know, if, for example, we stream HTML, HTML is usually like looks like a tree, like a DOM. And is it okay to stream parts of HTML to browser, so browser could render it properly? These are quick thoughts that I have regarding the streaming from the Rails side. So I hope I'm not so confusing.
I think that's incredible that you got it working. I would ask you to share your findings in the issue so we can also play with it. I think that's definitely something we can use for sending diffs as soon as possible. At least we should try it. I don't see why it wouldn't work with diffs as well. So that's really good.
Maybe let's share. Let's just discuss the performance implications later, but at least we can check whether it's a working solution from front-end perspective. Because, for example, Patrick investigating other solutions for diff highlighting. So if we can, for example, move it to Go service or Rust service, then streaming will be we will do our best to enable streaming there. So maybe it's a good iteration to do it using Rails streaming. Now front end works with the streaming response. Then we switch the backend to the Golang or Rust service streaming, and now no front end changes or little front end changes are needed. Just quick thoughts, but I'll share the findings. Thanks.
Yeah, I wrote it in the document, but I'll voice it. I think it'd be interesting to schedule a pairing session in the next day or so. I'll put it in the calendar, in the create stage calendar, so we can all see it and we can join if you want, and if you're available. Because I feel like this is something that is most beneficial if we just test it and go back and forth between the back end and the front end. So it'd definitely be interesting to see more strict collaboration there, just to assess. Okay. I had a question, like how does this get delivered to the front end, Stanislav? Is this server-side events or something?
Yes, I think it's using server-side events. I need to check if it's actually using TCP connection. It should be, because I'm kind of worried that diffs could be out of order or maybe missed. We should definitely verify that server-side events are working as TCP and the order is always correct.
Okay. So this is different from the technique you used on the streaming for the blame page, right?
The blame page doesn't use streaming in Rails at all. It uses just paginated requests because Rails doesn't really
I see what you mean.
work well with
You
that.
stream it to the rendering from the paginated request from the backend.
Yep, we only stream on the client. We cannot use streams on the server, but this can work with this approach. We can actually convert the server-side events into a stream and use that to render on the client. So it should work.
Okay. That's interesting. So for now, you're testing your proof of concept is only with the merge request, right? So using the diffs from the merge request. Okay. So Igor, one of the questions we have, I guess, is to assess whether these approaches would be incompatible or compatible with the way that source code or the repository is handling diffs on that side, because I think the code base differs a little bit. We don't have to have an answer right now, but for things to look into, that's something that we need to make sure that we don't get a solution that fits the merge request, but then the repository can't properly handle that. Cool. More thoughts on this point from Stanislav? Okay. Looking forward to the pairing session. It'll be interesting to see the outcomes of those. I'll try to join if I can. That takes me to the next point. Does anybody have any other points for this call before we go into that? That might be a bit brainstormy. No? Okay. So this is something that I alluded to yesterday on Slack, and we talked about it last week. But the thing that it's been on my mind and our mind, I guess, is the server-side rendering discussion. The server-side rendering proposal and proof of concept that we've seen from Stanislav is definitely promising, and it shows an avenue that it's worth exploring. So one of the things that I wanted to briefly discuss here is the way I see it. We moved away from the previous way we were rendering things because it made things faster to render. We started rendering the page much faster than waiting for the whole thing. So we made things asynchronous for that benefit, right? Going back to having things, even if partially server-side rendered on the back end, we need to ensure that whatever the size of the diff, whatever the context, that it will still be performant. And I wanted to briefly ask you, I guess, where do we see any bottlenecks on the back end from this approach? Because I remember Gitaly is changing some things on how we get changes from the change paths, and then we can get the change paths individually through the RPCs. Does that mean that we'll be able to, server-side render just the first 5 or n files more lightly than before? Or do we still have to have stuff like get the whole diff to be able to process the diff and then cut it in pieces. Like, does anybody have any thoughts on that?
Yeah, as far as I remember, Gitli is working on, as it was mentioned for Blame. Yeah, I believe it's like a similar approach. We paginate diffs, and yeah, it should, I think, dramatically improve the way we can fetch a small part of the diff, because we at first we fetch like the files that were changed in this particular diff. It should be fast, and then we like fetch 5 files from that list and receive like fast response. And like this optimization like should help us, and it's the opposite to what we do now. We fetch like the whole diff, and it can be like, well, it can time out even. Yeah, we have an issue that sometimes it's a timeouts because the diff is too large.
Got it. Thanks, Igor. So that definitely feels like the infrastructure behind Rails is getting better to fit this potential approach that we're taking. Okay. Patrick, you were going to say something, I think. You have any thoughts on that?
And I just agree with Igor. I mean, there's a slight difference with merge request, because for merge request is database back. The diffs are database back. The diffs are actually stored either in the database or the public storage. So it's, unless the user clicks on what do you call that, the ignore white space changes on the settings, which will fetch diffs from Qt. That's the only time it's going to fetch from Qt. But yeah,
That's interesting. Sorry, because I feel like the database part here. Do you have any backstory why we started doing? And I understand like there's caching and things involved that we don't want to hammer giddily, but why doesn't the repository do that? Why is it different? Like, what's the reason for the diffs? Is it because they're more repeatedly accessed? Do we know? Do we have any knowledge on that?
I don't know, historical knowledge, and I don't have it. But we use merge diff record because we track every version of them, right? Every push, it's one version. So we record in the database, so we store it so they can compare each version.
So it's essentially what it persisted in history, even if the Git changes. So I guess once you delete the branch, you still want to be able to see the merge request, right? So that's one of the reasons is the persistence.
Yeah.
Second. Okay.
And there's performance benefit as well, because instead of querying giddily or making requests giddily, we just fetch it from the database or donkey storage for the diffs. But I don't think it's not. It's possible to do that for repository for commits or compare, but it's not going to be efficient. Because there will be a lot of commits that we're not sure is going to be accessed right now.
Yeah, and I think there's some truth there where if I'm looking at a commit on the repository that doesn't exist, caching might be problematic. You know what I mean? Like if I make a mistake or something on a Git commit or something, and I want to rewrite the history on the repository, if GitLab cached it after I deleted it, there could be some potential, issues with that. So I think that repository being more close to the truth, to the true state of the current repository is expected. I wonder if the same issue would happen with the merge request, but I guess that's more of an edge case. But at least we have this understanding that there's a significant difference in the need for persistence in both scenarios. What I'm already thinking on top of this is that whatever persistence mechanism we choose, they need to deliver the front end the same response. So essentially, the front end will be unified for both scenarios. So the back end needs to, whatever structure it's done on the back, needs to deliver the same kind of like structure. That's something that doesn't exist today, but it will exist once we're implementing these new diffs part.
Just a couple of thoughts here. Yeah, I also don't remember that, like the initial reason why we sometimes persist commits and diffs in the diff files in the database, but at the moment I believe it's like for performance improvement. And as far as I know, we do it only for the latest version. Regarding the merge request diff versions, we like store only like metadata again. Yeah, like this SHA of commit was like compared to this SHA, and so you want the diff between them. Let's compare them, and the actual diffs, yeah, not diffs, like these commits, yeah, since we store it in the database, we store only SHA, but we also tell Gitly or Git to keep them around. And it's actually the literal word from the code base, keep around commits. Yeah, and so those commits are kept around. And if we want the diff between them, we just compare them on demand and show it. We cannot store the compare result in the, if we're talking about the compare page, we can store it in the database because because compare is usually like throwaway. We need it like only to have a look at it, and then we probably won't need it anymore. So storing it in the database maybe would be like waste of storage. So I believe those are the reasons why it works like this way. But yeah, I'm also can be wrong here.
Thanks, Igor. That's definitely valuable information and useful to know going forward. I'm trying to think the keep around commits and everything does have the impact of the repository storage, right? So essentially, we keep more data around the repository. I'm guessing if we don't do that, we don't do that for the merge requests, I guess, because like, at a certain point they will be disappearing, right?
We do it at the moment, but I believe Patrick has more information regarding the initiative yet to like optimize it to reduce the number of keep arounds that we have.
Yeah, I mean, still currently use keep around refs for merge requests because we want to keep the history, the commits. Because if we remove the keep around refs and then get garbage collected the refs, and we lose history. So there's still an ongoing discussion about it, what we want to do there. But,
okay.
Yeah, there were concerns from product perspective here that probably some users, they want the history of the merge request, but at the same time, if the merge request is too old, maybe it's not so useful to store all the diff versions history. So we have the ongoing discussions, but mostly from the product perspective.
So yeah, makes sense. So okay, I wanted to recover then the point of the partial access to diffs on Gitly feels like a killer feature for the server-side rendering approach. Stanislav, remind me again, we do, how many files do we render or server-side rendering to begin with? 5?
At least I've set it to 5 files right now. And also I think with virtual scrolling, we also do 5 files on the first render.
Sure, okay. So that means that we could align the way that the backend gets the data to make that first render as lean as possible. Well, we're assuming the first render, right? Because after that it could be cached. in some like database or other mechanism, but we're working for the first render to be fast because the other should be faster. So, okay, that's something that we definitely want to support, and potentially assume that we'll be there by the time. I'm wondering if it's a small merge request, we can kind of get that behavior already. But if it's a larger MR, we can't emulate that until Gitley has that implemented. But it'd be interesting to just to see that. I don't think we'll be able to wait until we have all of that in place. I think the development is ongoing, but I'm not sure how soon they will deliver the whole thing.
I have a question for Gitley. Can it send file by file? Not like requesting files and pages, but just asking it for the next file in the diff. Can it do that?
I'm not familiar.
We need Gitley experts here, I think.
Yeah, we do have it on the other call.
Could you please repeat the idea, the question? Yeah.
Yeah, instead of paginating diffs, sending them in pages, can we ask Gitley just send the next file? Like it maybe can keep some counter inside it, or we pass it as a parameter. Can we just ask it to send the next file that you have? Like basically split the diff using like string matching. If it's diff, what's it called? Maybe, I don't know, preamble split by these things and just serve the next file. It can actually be much better than sending files in pages, I think.
So, yeah, as far as I understand the question, so I think it's possible, but at the same time, probably the files approach, maybe it's a bit flexible. If it, for example, easier from front-end perspective to have it like this, yeah, like give me the next page, give me the next page. It also can be like encapsulated on backend. Yeah, for example, backend can do all this stuff regarding fetching the list of files, yeah, and then we can calculate based on the counter from the front end. We can calculate the list of files that we need from Gitley, and then we can send that request to Gitley and receive the list of files. So I think the quick answer is we can, yeah. For example, if it's not, if Gitley still decides to do it like this, yeah, like they plan to do it now, but from front end perspective, it would be convenient to have like a counter pagination. Then yeah, we can encapsulate it on backend, and so yeah, we can discuss it and see what is the most convenient way to do it. So yeah, I hope it answers the question.
I was thinking, is it something that Justin told us earlier about updates to Gitley? Can it support streaming out of the box? So if Gitley can actually stream the diffs to Rails, we can actually combine that with server sent events and basically do this in one pass. Because if we go with server sent events, you would prefer making the whole pipeline streaming based. So as much as you can stream, you should do that. If Gitley can support streams, that would be actually insanely good for us. I just don't fully remember what Justin told about Gitley updates.
Yeah, needs to be investigated. But as far as I remember, yeah, Gitley usually like streams the request, but I'm not 100% sure how Ruby and Rails actually, what is the interpretation of Ruby and Rails of that stream? Is it does it buffer the whole stream, or does it actually is it actually reading it like line by line? Yeah, you need to have a look. Yeah, but
Yeah.
I believe your question is whether we can glue it together with the like stream in the if we implement it. So in that case, it would be like even more optimal, to stream it from Gitly, stream the first chunk directly to front end, and do it in a pipeline. That sounds great. Sounds great.
Can you, Stanislav, can you start a thread on Slack and just tag Justin there? Because like we have him every other week on the call, but that way we can move that forward much sooner than that. Please, thanks.
Sure.
Cool. Yeah, if this feels like the last update we had from him is that they're working on detecting whether a file was generated, I think, to not display it. But the other parts that they were working before was the change paths, like having a RPC that gives you the change path so that then you can request them individually. So individually or in batch. So I think that's in line with what we want to do. So bringing this back a little bit to server-side rendering, what other bottlenecks are there on the back end? Because I remember, so this aspect of using the database has introduced a lot of complexity on the merge requests, especially when we have different versions, and then we started using comparing to the head of the target branch and that sort of thing. So there was a bunch of like confusing parts on that approach. So what lessons have we had in the past years that could potentially help us get to a better solution in how we handle the persistence of the data of the merge request? And I know Kerry has proposed in the past pre-calculating these data structures for the merge requests. So instead of keeping the raw representation of the diff, I guess we could keep that around in Gitly, but we would persist the rendered responses for well, I guess if you're using an API and GraphQL, you want to adapt the response to the request. So maybe that's not as straightforward as a JSON file. Where was I going with this? Yeah, so where, like, any other bottlenecks on the rest of the pipeline that we might have? I know we were investigating the highlighting, which is major. I think that's going to play a huge part. Is there any other things that are stopping us from leveraging cache on the template side? Like that's what Stanislav was looking into, right? That's what you mentioned before. So I feel like we already have that ongoing. I just wanted to see if we could identify any potential other bottlenecks that we need to look into ahead of time.
Yeah, currently, the current approach with diffs batch, one of the slowest part is serialization of diffs, which is, I think I brought it up like 2 weeks ago. So I brought it up 2 weeks ago about pre-caching it, the rendered response. So I think it's one of the things that we can do so to make it render faster.
So is that something is that something that we can POC? I don't know how much. So is it something that, what's the order of magnitude that we're talking about here? Like slower, when you say slower, what are we talking about? A couple of milliseconds, 100 milliseconds, a second? I would say like a couple 100 milliseconds.
Based on, we have that metrics. Right now it's around 1 second, the P90 for rendering. So I'm imagining like if it's pre-cache, it should be faster than that. I mean, if it's going to be fetched from Redis, it should be faster. But we have to ensure that storing it is efficient. That compared to before, like we did is we cache the response, but it's not efficient because we're generating a cache per user. So storage cost went up.
That is an important distinction, I think, because if I'm not mistaken, we're looking to have the templates be non-user specific. Stanislav? We've talked about it in the past. I'm not sure if the current implementation is taking that into account. And we wrote something here. Maybe it's related. So do you know if the templates that were server-side rendering, are they unique to users or can they be shared amongst users? Are we just rendering the diff part?
Could you repeat that? I don't
Yes.
fully understand.
So one of the problems we've had in the past is that every time we render, whenever we cache a response, there's so many things in there, and some of those things are specific to the users. So we could only cache them per user. So each user will have a different cache, cached representation. When we move to server-side rendering, we've talked in the past about, and we've talked extensively here about, we've identified that there's a bunch of content that is the same for every user. And then there's others that are not. The part that is server-side rendering, so the part that we're putting into the templates, is there anything in there, into those templates, that are user-specific, or could those templates be cached once and served to all users who need it?
That's the whole idea for splitting dynamic and static parts. So once we split that between static and dynamic and leave only static stuff on the server, we automatically get the benefits of caching. So we can have a stable key, cache key, that is shared with anyone. So anyone that goes to merge request gets the same cache key.
Okay, so but what you're saying is like the static part is what we're server-side rendering.
Yep.
Okay, we're server-side rendering static.
So for example, diff discussions probably won't be there. Like
Sure.
imagine you have an internal node in the diffs that is specific for some group. Yeah, you can't include that.
Got it. That's useful. So Patrick, coming back to the caching side, I know we want to have minimal impact or a measured impact on the Redis data store, Redis store in terms of like stored data. We don't want to crash it. We want to make sure that we're responsible with that. But that would decrease the number of things being cached from this diffs initiative, right? It would essentially be once per diff and not once per diff per user, I would say. Right?
Yeah. So there's one cache shared by all users.
Right. That's interesting. So from the discussion here and the things that Patrick and Igor you've been sharing, whatever new diffs architecture exists, it needs to be flexible to support throwaway cases and persistent cases of diffs, right? That's something that we need to account for in the way that the whole data flow goes through the pipeline, is that some of the cases might need to have it persisted. So that's sort of, does anybody disagree with that? Just going to write it here so then I can come back to this. Some scenarios require persistence while others don't. So that's like merge request diffs versus compare. Sort of put that, because I feel like this is definitely going to have to be a part of the architecture considerations or something. Okay. And then the caching part feels like we definitely need to investigate this a bit more. So right now, I think to validate that approach, I think it would be, who do we lose? Natale. To validate that approach, I feel like sorry, I lost what I was going. Yes, so figure out the template caching and figure out that Ruby delay and stuff that sounds like it's going to look into. But I feel like at a certain point, we might need to introduce some caching just to see how fast that really is. But it definitely feels like we're heading in the right direction with this potential approach. I think what might come of that is that we can employ some of the other ideas we've talked about, depending like the syntax highlighting optimizations, not highlighted, requested later, depending on the investigation that Patrick was doing. If it's fast enough, then we don't need to delay that. But if it's something that is pricey, we can delegate that to the moment that the user scrolls to it, and fairly seamlessly update it. So okay. So that kind of covers the caching topic. Any other considerations to the server-side rendering that we might want to look into ahead of time?
My main consideration here, and I'll return back to caching here, is that we probably will consume a lot of data on the Redis side and also on the database. So if we are storing compares in the database, and then we are caching rendered diffs, we are basically duplicating data between these two services. I'm not sure how infrastructure team feels about storing cache for diffs in Redis, because we might overload them actually. And we might not overload them, but it's not the amount of data that we store, but the amount of requests that we'll be making, because right now caching is per file based. So imagine you have 300 files. This will be 300 entries in the Redis cache. So 300 requests just by loading one merge request. I don't know if infrastructure is okay with that.
I think that depends on how we choose to make that, because you said one per file, but it could be that we compile the response and we cache the whole thing once we have the whole thing. Well, actually, no, you're right. If we're streaming it and if we're getting things piece by piece, it would be nice to have an effort of seeing how we could cache this. And I think that conversation happens after that. We need to forecast, and maybe we can get some data from production, like the number of different merge requests and repository commit pages that were accessed in the course of 7 days. So I feel like we'll get to a time where we need to do those calculations to forecast more or less the impact on the data store, on the cache store. Maybe we can start an issue to look into that, because that's like production data that we can, statistical production data aggregate that we can look into to get some lessons there. And it will always be forecasted, not exact, but it will be sort of like a way for us to get a ballpark measure, because that could affect what kind of store we use. But I feel like while we want to optimize for the first render, we want it to be robust enough so that subsequent accesses will be faster. So I feel like that's definitely worth a conversation and an issue, I guess. Any more thoughts?
I also want to say that I'm raising this point because when I did the streaming approach on my previous job, we tried the Redis cache approach as well, and it actually overloaded servers very quickly. So it increased the load by like 1000%, because we didn't expect that it would be so high. And for GitLab scale, I can imagine the same situation, because it's not just caching for the GitLab alone, it's caching for the all projects in GitLab cloud service, which is quite a lot, I think. So we definitely need to take that into consideration and maybe push it and optimize it as much as possible, because it can really impact infrastructure.
This reminds me that in the past we've talked about having a middleware between Rails and Gitly to cache the Gitly queries, because that would be a much lower level cache mechanism but it could potentially alleviate some of the complexity on the Rails side that we're talking about. Like instead of having to have like things persisted on the database and all that stuff, we could potentially flag some queries to Gitly to, you know, keep them around or cache them. Did we ever advance in that idea? Anybody knows if we did any research on whether that would be something worthwhile? Does anybody can anybody think of a reason why we shouldn't look into that at all? I know that Gitly gets a lot of requests, but on the Rails side, we have the knowledge whether those requests are throwaways or not throwaways, so we could potentially flag them in some way to, or in those cases, we would ask the middleware instead of Gitly directly. I don't know. It feels like it's worth investigating. I can't remember who voiced. Maybe it was Carrie. I think Carrie was on that call. If nobody remembers, I'll ping her to see if we did any advancements there, if it's worth revisiting. Okay. Anything else at this point? I think we have a couple of points to validate with Gitly and the Rails cache template caching and all that stuff. So we have some work to do to investigate this further. Is there anything else that anybody has in their mind that want to share on this topic? Stanislav, I had a question. So this server-side rendering approach, it means that we do have a duplication of templates, right? In some way, or is the template always server-side rendered, regardless of how it's requested?
It's always server-side rendered.
Okay, so even the subsequent requests get server-side rendered. Yeah. Okay. Right, I need to dig a little bit more into the BOC to get more acquainted with the solution. But yeah, I don't have any other thoughts, but this has been very useful discussion. Thanks for indulging in that. And I think the best news here that we've heard today, I think, is one, syntax highlighting match might be possible to do much faster with tree-sitter, maybe, possibly. That's nice. Because that, if we have tree-sitter sitting around, well, we could still have it regardless of the highlighting. We could potentially start doing other things. Sorry. We can start doing other things like understanding the file structure, and we can do smarter features on that understanding of the file. But for now, let's keep the investigation on the syntax highlighting. And the other part is the Gitly updates that could match this approach very well in making this first rendering much faster than it was in the past, and more than anything, robust. One of the things that I've looked at on the numbers that Stanislav shared is the difference between the two merge requests. So how much slower does it get with the size of the MR? And I know that we've talked about adjusting our performance budget depending on the size of the MR, but that we haven't advanced much there. Okay. Any other points? I'm just writing this before I forget. Okay. We might want to start an issue for this conversation of forecasting, like how many merge requests are accessed in the span of 7 days, plus how many repositories, merge request diffs, plus repository commits, plus compared pages. if you can get a number of access on those, we could get an estimate of how many diffs are seen, and we can typify that, and we can see more or less, again, the compared pages are throwaways. So we can ignore the compare page, maybe, I guess, I don't know. But for this case, it'd be interesting to get the numbers of these things just to, does anybody want to start an issue on that?
I can do that.
Cool. I don't know, I think in the past I've had a really interesting discussions about caching with Robert May from Source Code. He is part of this effort, whether he takes the call or not. So if we want to tap him to do some of those lookups, he might be interested in helping. But then I can ping him on the issue once you have that created. Cool. Let's keep this moving then. Thank you so much. We're at time. Anything else before we go? Great to see everybody. Thank you so much. It worked. I didn't want to do that. It would just happen. Bye, everybody. Great to